So there are a number of examples of equations here that we're going to solve, and we'll run into a number of special case scenarios. So starting with this very first one here, you can see that we got 9m squared minus 100 equals 0. So to solve this quadratic, we might try to factor this. So checking for a GCF first, there is no GCF of 9m squared and 100. So in terms of factoring this, just to note that 9 and 100 are both perfect squares, and there is no middle term, so we're just really factoring a difference of squares right here. So it does factor nicely as 3m minus 10 times 3m plus 10, and then of course you can just use the zero product property at this particular point. So either 3m minus 10 needs to equal 0, or 3m plus 10 needs to equal 0. So in one you need to add 10 to both sides, and then the other one you need to subtract 10 to both sides. So we end up getting that 3m needs to equal, oh, there we go, positive 10, or 3m equals negative 10, and you can divide by 3, and that's going to give you m equals 10/3, or that m is equal to negative 10/3. So those would be your two solutions for that particular equation right there. If you want to work your way through the second example right here, you're going to end up getting answers that k is going to equal plus or minus 1/2 if you want to work your way through that one, and just check your answer with that one. So I want to just jump to these last two in this row right here. So for 64y squared equals 36, if we want to try to solve this quadratic equation by factoring, then of course you want to have it set equal to 0. So one way we might accomplish that is by subtracting 36 to both sides. So that means then you would have 64y squared subtract 36 equals 0. And then we can take that left-hand side and try to get that factored nicely. Now there's actually a couple ways that we could approach this problem. So if I just factor directly, it does factor nicely as 8y minus 6 times 8y plus 6, which equals then 0. And then we can use the zero product property at this point. So that means that either 8y minus 6 needs to equal 0, or that 8y plus 6 needs to equal 0. So yeah, that means 8y equals 6, or 8y equals negative 6, and then you can divide by 8. So you're going to get 6/8, but that reduces nicely to 3/4. And then this here you'd get negative 6/8, which reduces to negative 3/4. So it does turn out that you get those answers that way. Now you could actually get your answers, I don't know, maybe somewhat faster or about the same speed maybe, because we actually didn't factor out a GCF. There was actually a GCF right there that we should have factored out. I think for 64 and 36, I think 4 would be the GCF. So if you factor out a 4 first of all, from that you'd end up with 16y squared minus 9, which is equal to 0. And then if you take a look at right there, the 64y squared minus 9, or the 16y squared minus 9, that's actually a difference of squares there as well. So you could actually factor further and make that like 4y minus 3 times 4y plus 3 equals 0, and then that's completely factored. And then by using the zero product property now, if 4y minus 3 equals 0, and then if 4y plus 3 equals 0, well, that's going to just lead you to your positive 3/4 answer, and that's just going to lead you to your negative 3/4 answer once you get everything solved all of the way. And then the last example that's in this row right here, if we check for a GCF first, I believe 75 and 48 are both divisible by 3. But also if you notice there's like that negative, the coefficient of the v squared, it's really nice if you factor out a negative. So if we do factor out a negative here, you're going to factor out negative 3 and then be left with like 25v squared, and that's going to have to turn to a negative, and it turns out that negative 3 times negative 16 is that positive 48. And then when you take a look at what's kind of left right here in terms of trying to factor that further, that's a difference of squares, because 25v squared and 16 are perfect squares. So you could factor that down to negative 3 times 5v minus 4, and then 5v plus 4 equals 0. So when you set that factor equal to 0, you're going to get an answer of 4/5, and then that would be a negative 4/5. So you do end up getting plus and minus 4/5 as solutions for that particular equation there. All right, so in all of those examples there in that row, really there was some difference of squares, factoring involved in them, and being able to solve and find solutions for the equation there. So when we jump to the next row, we're also going to see some special cases. So with this very first example, it's set equal to 0, and if I take a look at the left-hand side and try to factor that, first of all, there is no GCF of that particular expression, so we don't have to worry about that. You'll notice that 16a squared at the beginning is 4a times 4a, and then also 81 is 9 times 9, so you might guess that maybe it might be 4a and 9 and 4a and 9, but you have to check to make sure that really there would be a 72 from that if you would do 36a plus 36a, and indeed it does work out that way. So we end up getting that 4a plus 9 times 4a plus 9 equals 0, and then you can use the zero product property now. So that means that either 4a plus 9 equals 0, or, and then of course we get the same equation, so that means we're going to get the same answer but twice, right? So you would subtract 9 first from both sides, and then divide by 4. So we end up getting that a equals negative 9/4, and then of course again we would get a that equals negative 9/4. You don't need to write it twice, of course, right? So if you just say a equals negative 9/4 is the solution to the equation, then that's fantastic and great, right? So if we jump to this equation right here, you can see that, like, if you expanded that, that would be quadratic, where the highest exponent on g would be a 2, and you've got some quadratic stuff over here. So if we're solving a quadratic, right, you want to set it equal to 0. So let's at least expand this and then figure out what side we want to get our terms on. So if you expand it, you get 25g squared, and then plus 20g minus 20g simplifies to nothing. So then you just have negative 4 times 4 there, which would be minus 16. And then you still, of course, have these same terms on that right-hand side. So if we want to try to keep the g squared positive, then let's get everything onto this side. So let's cancel out the left side then. Let's subtract 25g squared. And then we'll have to do the same thing to the other side, of course. And then add 16 to cancel that out. So we'll add 16 to that side. So that means 169 minus 25 is 144g squared. We still have minus 120g. And 9 plus 16 is 25. All right, so then once you have it set equal to 0, right, then you can try to factor that expression that's on the other side of the 0. So in this case, we've got 144, which we know is 12 times 12, and then at the end we've got a 25. So we might think, okay, maybe it's 12g and 12g, and we can try 5 and 5. We have to make sure that we're going to get a negative 120 out of this. So if we make them both negatives, that's okay, because negative 5 times negative 5 is positive 25, and that would be negative 60g. Negative 60g does give you negative 120g. So we factored it correctly, still equal to 0, of course, and then we can use the zero product property where 12g minus 5 needs to equal 0, or 12g minus 5 needs to equal 0, right? So if you add 5 and then divide by 12, you end up just getting this one single answer twice from both of them, so you can just really just say that g equals 5/12 then out of that. And then these last two examples here are also kind of some special cases. The one on the left right here has a p squared term and a p term. So we know we can factor out a p, right, as at least a common factor, first of all. And then 49 and 63 are both multiples of 7, right? So we should be able to take out a 7 as well, giving us then 7p minus 9 as the other factor. And then that's beautiful, right? Because then we know if this factor times with this factor to equal 0, then either 7 times p needs to equal 0, or 7p minus 9 needs to equal 0. So if you divide by 7 on both sides of that equation, you get 0 as an answer for p. And then for this one, if you add 9 and then divide by 7, you get positive 9/7 as an answer for p. So those would be your two solutions for that particular equation there. And then for this equation right here, it is quadratic. So let's maybe, it's really nice if you can get the quadratic term to be positive though. So maybe if I add 10t squared to cancel that out, and then add 10t squared to that side, and then let's add 4 to cancel that out, because we're going to get a 0 on that side then. So I have to add 4 to this side as well to keep it balanced. So there's only one quadratic term there, and then there's the plus 2t, and then those would go together, but 4 plus negative 4 is 0, so I guess we just end up with that right there, that 10t squared plus 2t equals 0. So in factoring, check for a GCF first, and they both are divisible by 2 as well as a t. So if you factor out 2t, you end up with 5t plus 1 as the other factor. And then, of course, you can use the zero product property here at this point. So that means that either 2t needs to equal 0 or that 5t plus 1 needs to equal 0. So when you solve, then you end up getting that t equals 0, or that t is going to equal negative 1/5 for those solutions.